Warm greetings to all. So in this session, I am going to say about the concept of virtual instruments and sub-virtual instruments in LabVIEW. So here the VA, which stands for virtual instruments. So for creating a virtual instruments file, first in order to go to the LabVIEW software and then click the dialog box as a file, so and create a VA. So this after clicking those button, so the front panel window will be looking like this. So here the two inputs, namely A and B. So for example, you are going to add these two inputs. The block will be A plus B, and in order to subtract the two inputs, the block will be A minus B. So this is the block diagram window, which is having the nodes and the operation blocks and the input blocks, that is the control terminals and also the indicator terminals. So this is what looking like a creating a virtual block. So this empty block will be named as per the convenience. So LabVIEW programs, which is called virtual instruments. So here for example, if we are measuring the temperature of a particular block, means so the block will be appearing as a temperature, which is indicating the what are all the values and also what are all the modes. The one is Celsius mode or another one is a Fahrenheit mode. So here the front panel will be looking like this, and the controls will be the number of inputs. So and the indicators will be the number of outputs. So this is the block diagram. So it accompanies the program for the front panel. So it will be connected with the wires. So this blocks will be having the board ID and the channel input and also the voltage reading. So here the voltmeter and respective meters, in order to measure the voltage or current or power, the respective meters which is available in the dialog box. In order to pick those parts, we have to search the particular name with a particular name, and we can put it in the LabVIEW function. So here in order to convert the Fahrenheit to degree Celsius mode, the block will be available. So if the input is entered or input will be measured, so that respective input will be converted into either degree or Celsius, which is the user which can defined by the user. So this is what the LabVIEW programs, which is called virtual instruments. So the front panel will be looking like this. So after that we can select what will be the approximate temperature from the time period. For example, if you are measuring from 0 to 5 minutes or 10 minutes, the respective blocks will be placed in the front panel. So the front panel will be containing the double indicator and also the Boolean control. If we stop the indicator as press the stop button, so automatically the time will stop, and the flow which has been started from the initial time to the ending time will be measured in the respective block. So this is the front panel, which is having a panel toolbar, Boolean control and double indicator. So this is one of the example for measuring room temperature. So this waveform graph will be indicated as a result. So for creating a virtual instrument, so we need to create a front panel controls and the indicator. That is by pressing Ctrl E button, we can switch to block diagram. So and then have to indicate or remove the front panel objects to the desired position. So we have to keep the particular tables or particular blocks in the position, and using the sizing tool or positioning tool or select tool, we can place it in the virtual instrument block. So placing functions on the diagram and connecting the wires is another important parameter in creating a VA. So in order to access the room temperature, we need to place the proper blocks, inputs and the Boolean functions and the output blocks. So these are connected by the wires. So this is what wiring tips. So wiring will be look like in the three types. So one is that if we single click the mouse button, this type of wire will be appearing. When we'll double click the wire button, so this is what different alignments of wires. So this is what for spacebar by pressing the spacebar, we can flip the orientation and while wiring to take the wires down, we can easily simply track with the help of mouse. So this is what the wiring tips for arranging the block diagrams. So and then a sub VI. So a VI which can be created inside a VI, that is called a sub VI. So sub VI is the VI that can be used within the another VI. So what is the advantage? So it is some very easy connection and easier to debug. So if there is an error in a particular block, it can be separated, and it's a modular function and don't have to create another node. So for checking the error functions, and it requires only the less memory compared to the traditional method. So these advantages makes the virtual in order to create a sub-virtual instruments. So this is one of the part of taking a less memory and less time. So this is what more easier to handle. So this is the icon and connector. So the icon which represents the VI in block diagrams. So for example, if you are measuring the temperature icon which is showing the fluid will be shown in the block diagram, which is a icon, and also the mode, and the temperature connector which shows the available terminals for data transfer. So this is what the icons and the connector representation in the VI. So for creating a sub VI, so these are the steps to be followed. The sub VI is the VI which is inside another VI, that is virtual instrument. So first, in order to create the icon which is shown in the previous slide, and also to create a connector which is the help of wires, and also assigning the terminals. So for executing a virtual instrument, so these are all the major steps in order to execute a sub VI. So and also assigning the terminals, whether it is a input terminal or output terminal, and also save the VI after creating these, following the first three steps. So and then insert the VI into a top VI. So here the VI which is connected with the main VI which is indicated in the diagram. So this is sub VI. So these blocks which is having a group configuration and parameters and hard configurations. So these 5 blocks which is inside a entire VI. So for in order to measurement configuration, so these are all the 5 VIs which is executing inside a common or main VI. So it is having a device, groups, channels, and also the number of channels which is executed with the help of the particular function. So these function will be at last connected to the output block. So this output block will be containing the entire VI which is the output of the 5 VI blocks, that is a sub VI. So here the number of it takes a lesser memory to operate, and also faster execution is possible. So these advantages makes the sub VI to introduce or to run in the entire VI. So the virtual instrumentation, it makes the task to perform, and parallel operation is also possible, and also faster execution of the programs is which is very easily available. So this is what the advantages of having a sub VIs. So so far we have seen the how to create a VI in the LabVIEW, and also create a sub VI, and what are all the advantages of creating a sub VI in the VI part. So thank you for watching. Have a nice day.